This is Cameron Chai for azonano.com, and I'm bringing another episode of Azo TV. And today we're speaking to Curt Marcott for Anasys Instruments, and he's going to tell us about nanoIR and the new Polarization Control Technology.
Thanks, Cameron. Anasys Instruments has introduced a new product now called the nanoIR instrument that breaks the diffraction limit of infrared spectroscopy by allowing study of species as small as 100 nanometers. What's new on that technology this year is the ability to control the polarization of the laser so that you can get molecular orientation of information from molecules that are in your sample. And that's enabling us to do things like study single fibers. And there's some work here that's been done in collaboration with Bruce Chase, a longtime research fellow at DuPont, who's now retired and a professor at the University of Delaware, and he's doing extruding fibers of polyvinyl difluoridine. And one of the things they have not been able to do is to understand the molecular orientation of the fibers of single fibers. This technology, which couples infrared spectroscopy to atomic force microscopy, is enabling them to now get polarization information which shows that the spectrum of light polarized along the direction of the fiber is different than the spectrum polarized perpendicular to the fiber. And that can tell you something, for example, about the orientation of the CF groups in the chains and how these fibers are actually being formed. And that's a capability that's not been possible to be able to do up until now. The way the technique works is a pulse tunable IR source comes up through a zinc selenide prism, and an evanescent field is produced which goes through the sample, and actual absorbance is detected by an AFM tip. This enables the spatial resolution to be much smaller than the normal diffraction limited spatial resolution of IR spectroscopy, which is on the order of 3 to 10 microns. If the sample is thin enough, like these fibers, which are only 300 or 400 nanometers in diameter, we can achieve spatial resolutions of 100 nanometers. And so it's really a promising new technique for looking at a variety of different types of samples, including polymers now, where in addition to looking at polymer domains, we may be able to get some understanding of how the polymer chains are actually oriented within these domains. So I think this is a really exciting development, and we'll have applications outside in other polymer science, fiber extrusion, life science areas, including biomaterials like hair and skin even.
So Curt, being able to determine this sort of information, what will that mean, or what does it affect? What properties of materials does it affect?
The strength of a fiber. If the molecules are all in a line, a fiber doesn't stretch, and it can become much stronger than if the chains are going back and forth randomly. And this technology is able, as you change your processing conditions, enables you to determine if the fibers the chains are all aligned or not, and as a function of aging, whether that orientation degrades. And that's something that has been impossible to do at a single fiber layer, at a single fiber level, until this technology, which is just this new advancement of polarization control on the nanoIR instrument.
So you think that'll help us to develop stronger fibers effectively? Yes,
it may shorten the pathway to be able to come to the conditions to produce the best fibers that maintain their strength longer. In addition, if you're putting additives into fibers, you can see where they are spatially, and which you couldn't do with a normal FTIR microspectroscopy, because you don't have enough spatial resolution to be able to get to those levels.
All right, and if anybody wants more information about the nanoIR and this new polarization control technology, they can find that at the Anasys Instruments site?
Yes, anasysinstruments.com, or if they want to talk to me, I'm a scientific advisor for Anasys, and my consulting company is lightlightsolutions.com.
All right then, thanks for taking a few minutes to tell us about the nanoIR and polarization control technology.
Thanks, Cameron.